In this video, we're going to talk about reacting masses, another area of when we're talking about amount of substance. We're going to be able to calculate the mass of the product created when you have a mass of reactant, and vice versa. If you're given the product, work out how much of the reactant you actually needed. We're going to talk about limiting reactants or reagents. Okay, and we'll do some common exam questions as we go through. So reacting masses uses mainly this equation, which is moles equals mass over the molecular mass, MR, or the atomic mass, which is AR. Both have the unit G per mole. Now you're going to have to rearrange this at times, so we're going to keep it up into the corner of our screen. So we have 4.6 grams of sodium that's reacted with excess chlorine to produce sodium chloride. We want you to calculate the mass of the sodium chloride that's produced. Now in these questions you're commonly given an equation. You can see we've got our equation here. Okay, and they often tell you that something is in excess. Now what does the excess mean? So we've got excess here. That means I've got far too much chlorine. I've got loads of chlorine. Okay, so that means that however much I make of the product is based upon the mass of the sodium in this case, not the chlorine. The chlorine is in excess, so we ignore. So the most important point is we ignore it if it's in excess. Now let's start to go through how you answer the question. So we put this over here and we highlight the really important parts. We have 4.6 grams of sodium to start off with. So we have a mass. We also know our ratios from our balanced equation. So we can see that if there are 2 moles of sodium, I will make 2 moles of sodium chloride. If you simplify that down, that means 1 mole of sodium will make 1 mole of sodium chloride. It's a 1-to-1 ratio going across. Now we want to know the mass of the sodium chloride that we produce. So the first thing is we have to calculate number of moles. So this time we have to do the moles and the moles of the sodium. So the moles of the sodium, if you look at it, is our mass over our atomic mass. So that means our mass is 4.6, okay, which we get from our question. Okay, and then that is divided by the atomic mass in this case of sodium, which you get from the periodic table, which is 23. So 4.6 divided by 23 is going to be 0.2. Okay, so we have got 0.2 moles of sodium. Now if we've got 0.2 moles of sodium, that will mean, and we use a therefore sign here, so therefore you have 0.2 moles of Na gives, this is the really important thing to understand, if there's a 1-to-1 ratio, so there's a 1-to-1 ratio, that will give you 0.2 mole of sodium chloride. Okay, so 0.2 moles of sodium chloride. So it's a 1-to-1 ratio, 0.2 moles of the sodium will give you 0.2 moles of the sodium chloride. So now we're thinking about it in terms of the sodium chloride. We have to calculate the mass of the sodium chloride. So the question is asking for mass. Okay, so the question is asking for mass, and that is the mass of our sodium chloride. The mass of the sodium chloride is going to be equal, if we rearrange this equation, we want it to equal mass. We don't want it to equal mole anymore. So if you rearrange that equation, that means that the mass is going to be equal to the mole times the atomic mass. So the mole we know is 0.2. So that's 0.2, because we know there's 0.2 moles of sodium chloride. And then we times that by the molecular mass of the sodium chloride, which is 58.5. Now that, in the end, equals 11.7 grams in total. Okay, so we have got 11.7 grams. So all we're doing here is saying, right, what is the excess? What's in excess? We ignore that. Well, the excess is chlorine, totally ignored. Work out the moles of our reactant, that's our first step. So the moles of our reactant is worked out here. Moles of sodium, take the mass, divided it by the atomic mass. Then we used our ratio as we go across. We looked at our ratio, 1-to-1 ratio between these two things. And then that means that if you have 0.2 moles of sodium, you'll get 0.2 moles of sodium chloride. We rearrange this equation to equal mass. Mass is going to be equal to the molecular mass times the mole in this case. So that means your mole times your molecular mass, which gives you a mass in the end of 11.7 grams. So that means that 4.6 grams of sodium will give 11.7 grams of sodium chloride. Our next example talks about sodium reacting with sodium oxide. Now you can see from the balanced equation there is a different type of balancing. There's 4 here and there is 2 here. So our product that we want to work out is sodium oxide. Okay, and there's a 4:2 ratio, which is a 2:1 ratio here instead. And when it comes to reacting masses, you can often get 4:2 ratio or 2:1 ratios. You can also get 3:1 ratios, and you'll also get 2:5 ratios. But let's do this question anyway now. So the other thing we notice is that there is excess oxygen. So there's excess oxygen, which means we don't need to include that. So let's put it over to the side like we did before. Okay, and we've highlighted again our mass that's important of the sodium and the fact we want to look at the sodium oxide. And here is the sodium, and here is the sodium oxide. So all we have to do is, as we did before, same process. We're going to work out the number of moles of the element or the molecule that we know the mass of. So we know the mass of the sodium, so therefore we're just going to go moles of our sodium. That moles of our sodium is going to be equal to mass divided by atomic mass. So the mass is 9.2, okay, divided by our atomic mass, which is 23. I'm hoping that you're doing this with me and using a periodic table. And then that will equal 0.4. Okay, so that will equal 0.4. So we have 0.4, but the important thing is, if we go back to our therefore, okay, so therefore that means if you have 0.4 moles of sodium, will give, and we look at our ratio again, so we've looked at our ratio, we're going to look at, say, 2:1 ratio, that means 2:1, so 0.4 divided by 2 is 0.2, so that will give 0.2 moles, okay, of our Na2O, our sodium oxide. Okay, so our ratio 2:1, and that's what we've done. We then want to work out, and this is our last bit again, this is our mass, okay, of our Na2O. Okay, so that's our mass of Na2O. Mass of Na2O, remember the mass is going to be equal to the moles times AR, or the AR times the mole, or the MR times the mole, depending on what it is. So this is a molecule, okay, well it's actually a compound, essentially. And if we know the RFM, or the molecular mass of that compound, we can do this. So this is the molecular mass of it is 62. So that would be 0.2 times 62. And if we do 0.2 times 62, that is 12.4 grams. Okay, so that means that, go through this again just to make sure. Remember, you can go either way. So you might be given the product and then work back to the reactant. It's the same process. First step is work out the moles of the thing you know. Well, you know the mass of the sodium, and therefore you divide that by its atomic mass. That gives you the number of moles of sodium. You take the number of moles of sodium, apply it to the ratio. The ratio in the equation is 4:2, which is 2:1. So therefore I halve the 0.4, turn it into 0.2. That means I have 0.2 moles of the sodium oxide. To get the mass, I need to times that by its molecular mass. 0.2 times 62 is 12.4 grams. And that is how you do reacting masses with just solids. We'll go on another video to talk about how you do it with liquids.